In this problem, I have two equations that are both in slope-intercept form. So when equations are in slope-intercept form, I start at the y-intercept. Okay, I start at this number on the y-axis, and then I next use the slope, and I use rise over run to get to a second point. So I start at this point, I make a point, and then that's my first point, and then I use rise over run, and I get a second point, and then I draw the line. All right, so let's take a look. In this equation, my y-intercept is positive 6, so I'm going to start right here at positive 6. Notice I'm drawing a point. I'm not just putting my pencil there and then counting rise over run. I'm actually drawing my first point there. Now, my slope happens to be a whole number here, so I make it into a fraction by putting it over 1. And so then I have my rise over my run. So in this case, my rise is negative 3. Now, rise means to go up, but if my rise is negative, I go down. So I'm going to go down 3. And then my run is positive 1 to the right 1. Okay, now on paper, you can do it again to make it neater. I can go down 3, right 1, down 3, right 1, right? On the computer, you'll just plot the 2 points and it'll be nice and neat. Okay, but here's my first line. Now, my second line, here my y-intercept is negative 3, so I'm going to start at negative 3. Notice I'm never starting on the x-axis, ever. I'm always starting on the y-axis of the y-intercept. My rise is 3. And my run is 2. Okay, again, I can go of 3, right, 2 again if I want to make my line neater. On paper, on a computer, it doesn't really matter because the computer does it for you. Okay, so here are my 2 lines. And then on Edulastic, you'll have to put a point at the solution here. We're going to circle it. The solution is where the 2 lines meet, so it's right here. Okay, you go ahead and try this one.